Now we've come to the op amp, the operational amplifier. So we're going to get an introduction here to the op amp and try to understand a little bit about it. We're not going to go too deep. The idea behind the op amp then is to look at an integrated circuit that does the job of a discrete amounts of components and see what we can do to understand the operational and amplifier characteristics then of this device. So we're going to discuss the basic op amp and explain a basic operation of a differential op amp. How much we get into these others is yet to be seen. You're just supposed to get an overview. The operational amp, the differential amp, other terms, single-ended mode, differential mode, common mode. There are lots of terms in here. For those of you that will take the advanced classes, you're going to get all of the op amp experience you're all you can stand. You're going to enjoy all you can stand. So early op amps were used primarily to perform mathematical operations such as addition, subtraction, integration, and differentiation. Hence the term operational. These early devices were constructed with vacuum tubes and worked with high voltages. Today's op amps are linear integrated circuits, ICs, that use relatively low DC power supplies and are reliable and inexpensive. So what does a op amp look like? How is it packaged? What's the symbolism? The standard operational amp symbol below in A and B. It has two input terminals, the inverting input and the non-inverting input, marked negative and positive, and one output terminal. The typical op amp requires two DC power supplies, voltages, one positive, the other negative, as shown. Usually these DC voltage terminals are left off the schematic symbol for simplicity, but they are always understood to be there. We can see below that what the typical package looks like. Typical packages in C, the DIP, SOIC, PLCC are all package types for the operational amp. Again, you will see these when you get into the op amp class. To illustrate what an op amp is, let's consider its ideal characteristics. A practical op amp, of course, falls short of these ideal standards, but is much easier to understand and analyze the device from an ideal point of view. The ideal op amp has infinite voltage gain and infinite input resistance, or an open, so that it does not load the driving source. Input resistance is sometimes called input impedance. Also, it has a zero output resistance. Output resistance is sometimes called the output impedance. These characteristics are illustrated in the diagram below. The input voltage Vn appears between the two input terminals and the output voltage AV/Vn as indicated by the symbol for internal voltage source. The concept of an infinite input resistance is a particularly valuable analysis tool for the various op amp configurations. Okay, so we can see here in this symbol here where we've got all of those functions labeled on the op amp diagram. Notice here that they tell you the gain is infinite. For a practical op amp, although modern IC op amps approach parameter values or the parametric values that can be treated as ideal, in many cases the ideal device has never been made. Any device has limitations. As they say, there's no free lunch, and the IC op amp is no exception. Op amps have both voltage and current limitations, as do many discrete components. Peak-to-peak output voltage, for example, is usually limited to slightly less than the two supply voltages. Output current is also limited by internal restrictions such as power dissipation and component ratings. Again, you got to remember how big these things are. I mean, these things are smaller than a chiclet, a piece of gum. Output current is also limited then to these ratings. Characteristics of a practical op amp then are high voltage gain, high input resistance, and low output resistance. So we can see the diagram below and how it differs from the previous one for the ideal. Okay, so get an idea between these two representations of the op amp, the practical and the ideal. The internal block diagram for an op amp then shows you that it has a differential amplifier input stage, voltage amplifier gain stage, push-pull amplifier output stage. A typical op amp is made up of these three different types of amplifier circuits. A differential amplifier is the input stage for the op amp. It has two inputs and provides amplification of the difference voltage between the two inputs. The voltage amplifier is usually a Class A amplifier that provides additional op amp gain. Some op amps may have more than one voltage amplifier. A push-pull Class B amplifier is used for the output stage.